Okay, so we are going to now start in chapter 10. And chapter 10 is all about acid-base titrations. As always, we start with some key terms and objectives. We want to know what indicator error, Kaldal analysis, and the definition of titration curve is at the end of this chapter. And more importantly, there's a long list of objectives. These are things that you'll need to know how to do once you complete this chapter to do your quiz questions for today, and also to succeed on exam number 2, which is coming up. Okay, so I want to pay attention to these things. Hopefully, over the last couple days when we've been talking about acid-base chemistry, we've laid a foundation for understanding how to consider computation of complete titration curves. Because actually what we're going to be doing in this chapter is actually constructing or calculating a graph of pH versus titrant volume. Okay, pH versus titrant volume. Now, let me draw that out if I can real fast here. You make a titration curve. pH is always going to be your y variable. And titrant volume is going to be your x. Now, this is the volume of the stuff that you put inside the burette, okay? Usually, this is volume, usually in milliliters, okay? But I guess you could use other units, just milliliters is most common. And these curves can appear slightly different shapes, and in this chapter, we're going to be learning about them. But what characterizes generally all of them is that you'll start at either one extreme of pH, either high or low, sometimes in between, and then you'll go through a region of dramatic change in pH. And the steepest region on our curve, we'll have the highest first derivative, as we'll soon learn, is going to be our equivalence point, our endpoint of our titration. Now, we're going to consider many different acid-base titrations in this chapter. We're going to consider titration curves for strong acids with strong bases. We're going to also consider titration curves for weak acids with strong bases. We're going to consider strong acid, weak base titration curves. And we're going to actually learn how to compute these graphs sort of from the chemical reaction and the pKa of the compounds of interest. And when I say compute these graphs, what I want you to be able to do ultimately is to compute the pH at every single titrant volume along the curve. Okay, it doesn't matter where we're at on the plot, we need to know how to compute the pH at every spot along the curve. Now, to do this, we'll have to recognize that there are going to be several different regions on the curve. The first one is going to be here when 0 titrants added. In through here is where we're going to have excess sample. Again, the steepest portion of our curve is going to be the EQ point, the equivalence point. Okay, that's right there. And then up here, we are going to have excess titrant because we added too much, okay? So there's always these different regions on the curve. This is excess titrant. Always these different regions on the curve. And once we study these different regions a little bit and learn how to do the calculations, we are going to be able to compute the pH at every point along this curve. And that is a major, major, major learning objective for this chapter. In addition, once we do that, we practice this a little bit. We're going to start to see how the shapes of these titration curves differ a little bit, okay? Whether they start at low pHs and go high, like the one I've drawn, or maybe they start at high pHs and go low. They have slightly different shapes in between. So let's study how these shapes differ, and we'll get at that in this chapter, okay? Another thing that's real important is number 5. We are going to learn about several different methods to find the endpoint of an acid-base titration. There's going to be graphical methods that I'm going to teach you all about called the first derivative and second derivative methods. And we'll also discuss use of indicators. Again, this is those color changing compounds. I'm going to now ask you to know how to choose a good indicator for a particular titration, and you're going to be able to do that because we're going to be able to predict the pH at equivalence, right? If you know the pH at equivalence point for an acid-base titration, you should be able to match a good indicator to that, okay? You want the color to change at the pH at equivalence. We're also going to talk about a very specific method of acid-base titration. Sometimes students think that we just do this in the lab and in early chemistry classes, and it doesn't really have much practical use. But it turns out that there is a relatively famous method called the Kaldol method that's really rooted in acid-base chemistry, acid-base titration. And the Kaldol method is used worldwide in many labs, as it turns out, for the measurement of nitrogen in a variety of different samples. This could be foods, pet foods, lots of different samples. It's oftentimes used in the food industry. And in fact, a few years ago, there was a bit of a problem. Certain manufacturers of pet foods were adding a compound to their pet food, which was bad for the animals. I think it caused them kidney failure, and many animals died. But they did that because this particular compound had a ton of nitrogen in it. And it turns out that this Kaldol method, while it's used worldwide because it's relatively low cost and familiar to people, it's not so selective for what kind of nitrogen it's measuring. Now, for this pet food analysis I'm telling you about, high quality pet food often has a very high protein content, right? We like to have a lot of protein in our food, right? Same for pet food. Now, protein has nitrogen atoms, of course. This Kaldol method, though, it can measure protein nitrogen, but it's not selective. And what I mean by that is it cannot differentiate nitrogen which originated from proteins from nitrogen that originated from other substances. So this company found out that if they adulterate the pet food with this cheap, inexpensive substance that has a lot of nitrogen in it, that they were actually able to sort of fool the analysts that were performing this Kaldol method. When they did the method, the Kaldol method, it seemed like the pet food had a tremendous amount of protein, which makes it high quality. But in fact, it was just adulterated with this other compound. And unfortunately, that compound was dangerous for pets, and many fell ill. So a true story, okay? So this Kaldol method is actually still used. And then if we have a little bit of time, we'll talk about primary standards for acid-base chemistry. But to be honest, I showed you that plot a few chapters ago, and that story hasn't changed, okay? So that's more or less the same as before. But our big focus is really to achieve these calculations. I want you to know how to do that. I want you to know how to figure out how to find the endpoint, this first and second derivative methods, and then a little bit about this Kaldol method. All right, now I wanted to do this introduction slide as a standalone video because the subsequent videos I'm going to break down into individual topics, okay? The next video will be how to compute pH of a strong acid, strong base titration. And then we're going to talk about how to do it for a weak acid, strong base titration. And then we're going to have a video for how to do a weak base, strong acid titration, okay? And then I'm going to come back and we'll talk about the curves and the indicators and the graphical methods. So each of these objectives are kind of broken down in their own video. And I just wanted to let you know that that's how I've organized this content. I hope that's easy for you. Over the last year and a half, we've heard that taking these little snippets, 10, 15-minute videos is usually good for students, okay? All right, so let's get started in chapter 10. I hope you all are doing well.